Hello students, we have already studied about physical properties of carbon compounds. Let us now study the various chemical properties of carbon compounds, in which we will know what kind of chemical reactions they take part in. They mainly give four types of chemical reactions, which are combustion, oxidation, addition, and displacement reactions. As the name says, combustion is burning. That means we will see what products are formed when carbon compounds are burnt in presence of oxygen. Similarly, oxidation will involve the reactions of carbon compounds with oxygen. The addition is where new atoms or groups of atoms get added to the carbon chain. While unlike addition, in substitution, one or more H atoms or functional groups in the carbon chain are replaced or substituted by other atoms or groups of atoms. So let us first know about combustion reactions. Have you ever observed either a coal fire in factories or a bonfire of wood? What is the first thing that comes to your mind? Yes, we say that they are burning. However, the question is, what happens at the beginning of the burning of wood or coal? When wood or coal is burnt, it initially ignites with a yellow flame and also produces black smoke, isn't it? Yes. Compare this with a burning candle or LPG in the gas stove. We see that they burn with a bluish flame and no smoke is produced. In fact, when coal is burnt in agate, it doesn't even produce a flame, it just glows up, isn't it? Yes. But why does this happen? Why does every material used here like wood, LPG and charcoal all burn differently? Aren't they all made up of hydrocarbon compounds? Yes, they are indeed. But there are two important considerations here. One is the type of compound which is burning and the other is the way in which these compounds are burning. Let us take the first case. When we say which compound is burning, we say they are hydrocarbons. That is obviously correct. But here we want to find out what kind of hydrocarbon compound is it which is burning. Which means we are interested in knowing whether they are saturated or unsaturated hydrocarbons. Do you know which compounds are present in LPG? Yes, they are gases like ethane, butane, etc. Can you tell me which type of hydrocarbons are they? Clearly, saturated, as they belong to alkane series. So do I mean that saturated compounds like methane and butane burn with a clear blue flame? Yes, it's true. And why so? It is because during burning, the older carbon bonds break and newer ones are formed with the help of oxygen. Let us say when we burn methane, all the bonds will break and this carbon will combine with oxygen to form carbon dioxide, and hydrogen will combine with oxygen to form water. Along with this, energy in the form of heat or light is also released. So in the case of saturated hydrocarbons, the oxygen atoms are able to break these single covalent bonds very easily. However, in the case of unsaturated hydrocarbons, the same number of oxygen molecules is insufficient to break the double and triple bonds present in the compounds. It's because more oxygen atoms would be required to break double or triple bonds. So one thing is that it is the presence of single, double or triple bonds present in the compound that will result in blue or yellow color of the flame respectively. To state it simply, saturated hydrocarbons which are present in LPG or other fuels would burn easily to give a blue flame, and unsaturated hydrocarbons present in wood or charcoal would burn insufficiently in the same quantity of oxygen to give a yellow flame. What did I just say? Insufficiently. Yes, I did. This is our second consideration. So what do I mean by sufficient or insufficient quantity of oxygen? And what has it to do with the type of burning of carbon compound? We just said before a while that the same quantity of oxygen will easily break single bonds but will prove insufficient to break double and triple bonds, isn't it? Yes, this clearly indicates that there will be incomplete burning of these compounds. As all bonds are not broken down, double and triple bond remain as it is. Yes, I said that unsaturated compounds undergo incomplete burning. Also, only when gases are burnt does a flame appear. Solids usually do not burn with flame. When heat is given to molecules of gaseous matter, they burn with a luminous flame and start to glow. Here we know that carbon compounds with fewer carbon atoms, say up to 10 to 15 carbons in a chain, are highly volatile and exist as gas. When they are ignited, they burn with a flame. And this is why LPG, which contains gases like methane and butane, burns with a blue flame, while the hydrocarbons present as solids burn with a yellow flame. And this is why coal or charcoal, which have higher hydrocarbons, do not give a flame when burnt in angeti, or even if they produce a flame, they burn with a yellow smoky flame. In this case, they glow and give off heat, but not any kind of flame. Now coming back to our discussion, when solids like wood or coal are burnt, initially the volatile substances present in them vaporize and burn with a flame very quickly. Due to this rapid burning at the upper surface, the lower surface of the wood does not get sufficient oxygen, and there is incomplete combustion of carbon compounds present here, and thus burn with yellow smoky flame. Therefore, because of their incomplete combustion, they give off a yellow flame and produce black smoke, which is made up of carbon. Right. Incomplete burning of hydrocarbon compounds give a yellow, sooty or smoky flame. In addition, we know that fossil fuels such as coal and petrol, which are formed from biomass due to various biological and geological processes, also contain unsaturated hydrocarbons, and thus they undergo incomplete combustion and cause air pollution. So students, we now know the reason that why different hydrocarbon compounds like LPG, coal and wood burn differently, producing either different kinds of flame or sometimes not even producing it, simply just glowing. In the coming videos, we will see some more aspects of combustion of hydrocarbon compounds.